We are doing a deep dive today into, well, the engine room of the modern world, machine learning.
Right.
And the goal here is to give you a sort of conceptual map of how it all works, why it's so critical, and this philosophical battle that's happening.
A battle between 5 rival schools or tribes, all racing to build the ultimate learning system, the master algorithm.
And you really don't have to look far to see ML in action. I mean, it's pretty much involved in every computerized thing you do from the moment you wake up.
Oh, absolutely. It's often totally invisible to you.
Think about it. Your smart thermostat, maybe a Nest, it's already learned your schedule to save energy.
Right.
You do a search on Google, ML is ranking the results, it's serving you ads, your car is using it to optimize fuel.
Even traffic apps like Inrix
Yeah.
or Google Translate, or when Bing Travel tries to predict if a flight price is going to go up or down.
That's all machine learning. It's your personal DJ, your editor, your travel agent.
It really is.
Yeah.
We are so far past ML being some niche tech. It's basically the operating system for how knowledge works in our society now.
Okay, so let's unpack why it became so necessary. I mean, why did we move away from traditional programming? Historically, you just told the computer exactly what to do, step by step.
We did, but the world just got too complex to program it all explicitly. A spam filter is a perfect example.
Right.
If you write a rule that says flag emails with the word Viagra, the spammers just change it. They'll write Viagra or use an image instead. A human programmer can't keep up.
And there are some things we don't even know the rules for ourselves. You mentioned self-driving cars. How do you even begin to write down every single rule for driving?
You can't. It's impossible. No one can write down a perfect set of rules for every possible pedestrian, every pothole, every weird glare on a traffic light.
So the learning algorithm just bypasses that. It learns the patterns directly from watching millions of hours of humans driving.
Exactly. ML is the answer to that kind of insane complexity and data overload.
And that data overload, which really came from the internet, it created this other huge problem, the unlimited number of options.
And this is so critical for business, this idea of the long tail.
Okay.
So a company like Netflix, they might have thousands of obscure documentaries. But without a recommendation system, what happens?
You just pick the 10 movies you've already heard of, the blockbusters.
Precisely. That huge variety, that long tail, is useless unless you can connect a person's specific taste to a specific documentary.
And that's what the ML system does. It makes the long tail profitable.
It monetizes it, yeah.
Yeah.
It turns infinite choice from a problem into an asset.
Which brings us right to the economic arms race this has started. I mean, people are comparing ML's impact to the steam engine or the automobile.
I think that's a fair comparison. It's a foundational shift. Look at the classic story of Google versus Yahoo, way back when.
They were both just trying to predict which ads people would click on, right?
Both using learning algorithms. But Google's was just a tiny bit better, marginally more accurate.
And that small difference was enough to...
It was catastrophic for Yahoo, because even a 1% better prediction, when you multiply it by billions of searches a day, translates into billions of dollars of difference in market value.
So for a big business now, adopting ML isn't really a choice. It's about survival.
It is. If your competitors are still trying to write thousands of rules by hand, and your algorithm is learning billions of them automatically from data, it's not a fair fight.
It's been called spears against machine guns.
It really has. And in that fight, data is the new oil. And learning how to refine that data into knowledge, well, that's the big business of our century.
All right, so now that we get the why, let's get to the how, the 5 tribes. Because ML isn't just one thing, is it? It's more like 5 different religions, each with its own idea of what learning even is.
That's the perfect way to put it. And if you understand these 5 tribes, you basically understand the entire landscape of AI research. So where should we start?
Let's start with the one that's all over the headlines today, the connectionists.
The brain-inspired tribe.
Right. They think knowledge is stored in the connections between neurons, just like in our heads.
Their core idea goes way back to a rule by Donald Hebb. Neurons that fire together wire together. The strength of that connection is the knowledge. Their first big invention was the perceptron.
And the perceptron hit a really famous wall, the XLR problem. It basically killed AI research for a decade.
It did. It's a fascinating bit of history. A simple perceptron could only learn things that were linearly separable. Imagine you could draw one single straight line to separate all the yes answers from the no answers on a graph.
But XOR, which is exclusive OR, you can't do that. It's like saying you'll buy Nike shoes if you're young or are a woman, but not both.
Exactly. Young and male, yes. Old and female, yes. But a young woman, no. You can't separate those points with one straight line. You need a curve.
And the perceptron couldn't make a curve.
Not until 1986, with the invention of backpropagation. That was the masterpiece that solved it.
So what does backpropagation do, in simple terms?
It's a way to handle error. It sees the final mistake, the wrong output, and then it sends that error signal backwards through the whole network.
Ah, okay.
It adjusts the weight of every single connection just a tiny bit to reduce that error. It's how these multi-layered networks learn. For connectionists, backpropagation is their master algorithm. It's the engine of deep learning today.
That makes sense. Okay, tribe number 2, the Symbolists. And they could not be more different.
Complete opposite. They think learning is all about finding rules. Human-readable logic.
Like if this and E that are true, then this other thing is likely.
That's it. They're searching for those logical structures. The classic, maybe apocryphal story is the one about Walmart, diapers, and beer.
Right, the discovery that people who buy diapers on a Friday night also tend to buy beer.
Seems random at first, but a symbolist would induce the rule. Maybe a tired parent sent to the store for diapers grabs a six-pack as a reward. The beauty is you can understand the rule. But they had a huge problem.
Overfitting.
Overfitting, the central problem of all machine learning.
Which is when you learn patterns that are true in your data set, but they're just random noise out in the real world. How do we explain that?
The best analogy comes from literature. Jorge Luis Borges wrote about a character, Funes the Memorious, who had a perfect memory.
He remembered everything.
Everything. Every leaf on every tree.
Yeah.
But because he remembered every single detail, he couldn't generalize. He couldn't understand that a dog seen at 3:15 p.m. was the same dog he saw at 3:15 p.m. from a slightly different angle.
Because the details were different. He was overfitted to the data.
Exactly. Learning is forgetting. It's about forgetting the irrelevant noise so you can remember the important signal. We talk about it as a trade-off between bias, which is being too simple, and variance, which is being too complex and overfitting.
Blindness versus delirium.
That's the one. You have to find the balance.
Okay, on to tribe 3, the Bayesians. Their whole world is probability and updating your beliefs.
For them, learning is all about Bayes' theorem. You could call it the F equals ma of machine learning.
So you start with a belief, a hypothesis.
A prior belief. And as you get new evidence, new data, you update that belief. The hypotheses that match the data become more probable, and the ones that don't, they fade away.
And their workhorse model is the naive Bayes classifier. What's so naive about it?
It makes this really big simplifying assumption that's almost always false in the real world.
Which is?
That all the different features or effects are independent of each other, given the cause.
And even though that assumption is wrong, the model works surprisingly well.
Incredibly well for things like spam filters or classifying text. It proves that famous saying, all models are wrong, but some are useful. You're often better off with a simple, fast model that can chew through tons of data than a super complex one that's too slow to run.
But doesn't calculating all those probabilities get, well, computationally insane for really big problems?
That is their big challenge, yeah. When you have millions of features, the math just explodes. They have to use a lot of tricks, like sampling and approximations, to make it work.
All right, that brings us to tribe 4, the analogizers. For them, it's all about similarity.
They argue that all of human thinking is basically just a giant web of analogies. If two things are similar, one makes you think of the other. It's as simple as that.
And their main algorithm is called nearest neighbor, which is funny because it's described as the fastest learner. It does nothing during training.
It's the ultimate lazy learner. It just memorizes every single data point. That's the training.
So it pays the price later.
It pays the price at query time. When you ask it a question, like classifying a new photo, it has to search through its entire memory, billions of photos, to find the single most similar one, its nearest neighbor.
That sounds slow. How do Amazon and Netflix use this idea to give you recommendations instantly?
We use a clever version of it called collaborative filtering, and it's built on this deceptively simple idea.
Okay.
The idea is that people who agreed in the past are likely to agree in the future.
So if you and I both like the same 5 sci-fi movies, and then you watch a 6th one that I haven't seen, the system will just assume I'll probably like it too.
That's it, exactly. Or, people who bought this book also bought that book. That simple idea drives something like 1/3 of all of Amazon's sales.
Wow. And they have a more advanced version too, right? The support vector machine.
Right, an SVM.
Yeah.
Instead of just finding the nearest point, an SVM tries to find the best possible boundary line between two groups of things.
Like spam and not spam.
Exactly.
Oh.
And it draws the line with the biggest possible margin of safety, meaning it's as far away from the closest examples on both sides as it can be. It's the most confident dividing line you can draw.
And finally, that leaves us with the fifth tribe, the evolutionaries.
Darwin and a computer.
They just apply natural selection, but to algorithms instead of animals.
Right. Learning happens through competition, mutation, and reproduction. The best algorithms survive and combine to make the next generation. Imagine a robotic park factory where robot designs compete, and the most successful ones get to 3D print their children.
So the learning isn't in one robot, it's in the whole population evolving over time.
Precisely. And what they're constantly managing is a fundamental trade-off.
Explore versus exploit.
The universal dilemma.
Mm-hmm.
Do you exploit the solution you already know works well, keep playing the same slot machine that's been paying out? Or do you explore a new, unknown machine that might be even better?
But also might be a dud.
Right. And evolutionary algorithms have to constantly balance that, devoting some resources to getting better at what they know and some to searching for brand new ideas.
So when you look at all five, connectionists, symbolists, Bayesians, analogizers, evolutionaries, it's pretty clear no single one has all the answers.
Not at all. The symbolists are good with logic, connectionists with perception, Bayesians with uncertainty.
So the real quest, the hunt for the master algorithm, is about finding one learner that can unify them all.
That's the holy grail. The sources call this unified theory alchemy. The idea is to combine the strengths of all five tribes into a single universal learner.
So it's a unifier, kind of like how the internet unified all these separate computer networks, or how electricity unified energy.
A perfect analogy. And the proposed mechanism to do it actually combines two of the tribes we just talked about.
Okay.
It would use genetic search, like the evolutionaries, to find the best high-level structure for the model.
And
then uses gradient descent, which is the main tool of the connectionists, to fine-tune all the parameters inside that structure.
can you just quickly remind us what gradient descent is?
Sure. Imagine you're standing on a foggy hillside. You want to walk to the lowest point in the valley. The lowest point is the lowest error. You can't see the bottom, so you just feel the ground at your feet and take a small step in the steepest downward direction. You just keep doing that.
So evolution builds the brain, and then experience gradient descent wires it.
That's the idea. It mirrors how nature does it. Evolution creates the biological brain, and then learning from experience shapes the connections.
But this whole arms race towards a master algorithm, it brings up some really serious questions about data. Because if the algorithms learn from data,
Then whoever controls the data controls the learner. That's the single most important insight here.
and day by day, we're all creating this digital mirror of ourselves.
Every search you make, every email you write, where your phone goes, your health records, it's all being aggregated into this digital you.
A digital you that's worth, what, potentially trillions of dollars a year? But individuals see almost none of that value.
The power imbalance is massive.
Yeah.
A corporation can collect and use data on a scale an individual can't even comprehend. You have basically zero power to negotiate how your own data is used.
Which is why people are starting to talk about the idea of data unions.
It's a cooperative model, essentially. Instead of you trying to negotiate with Google alone, which is hopeless.
You pool your data with millions of other people in a union.
Exactly. The union then has real collective bargaining power. It can negotiate with companies on behalf of its members for fair compensation or for rules about how the data can be used. It levels the playing field.
And the argument is that we might be too focused on just privacy, on things like the right to be forgotten, when the bigger issue is how the data is used for good.
I think so. Privacy is crucial, but just locking data away can be a huge loss for society. Think about cancer patients. If they could all agree to securely share their data through a union, we could probably accelerate cures for future patients immensely.
So the goal isn't just to hide the data, but to make sure its benefits are shared by everyone.
We've covered a lot of ground here, from just how common ML is to the economic need for it, and then through that whole intellectual war between the 5 tribes.
The connectionists, symbolists, Bayesians, analogizers, and evolutionaries, all searching for that one unifying master algorithm.
And as we get closer to that, you have to think about the speed of change. This probably isn't going to be a slow, gradual thing. It's more likely to be a phase transition.
Like popping corn or water boiling. Nothing, and then a sudden, rapid transformation.
Kind of Turing point.
And that speed means we have to be careful, especially as these systems get more autonomous, military robots. We have to think about teaching them ethics.
And this is the fascinating part. Because human behavior often violates our own ethical codes. The biggest benefit of teaching ethics to a robot.
Might not be what the robot learns.
It might be what we learn about ourselves when we're forced to teach them. It makes us confront our own contradictions.